factors that affect climate. Yay, our topic for today. First thing that we need to do is understand what exactly climate is, and I always start by recapping the difference between weather and climate. So, weather is a short-term atmospheric condition. You can think day to day, hour to hour, the type of thing that you check your weather app for to see if can you do sport, are you going to be staying indoors today, or is your house going to be snowed over? Okay, so it's very short term. It's over a couple of days, maybe a couple of weeks, and those are the four things that we generally look at when we look at weather. So normally temperature is our first point of interest, then precipitation like rainfall, humidity. We're not always conscious of humidity, even though we're sometimes aware of it. So like we'll have a hot day and it's unbearably hot. It's just draining. That's usually your very humid days. You feel clammy and sweaty and just unpleasant. Then if you have a dry heat, it somehow doesn't feel as unbearable as those very humid conditions. So we don't realize that we notice it, but we do actually know. And then wind. So Cape Town is known to be the windy city, so we are very familiar with the wind. But the wind can be very interesting if you are maybe a sporting person, maybe you want to go for a cycle, you want to go kiteboarding or something like that. Then you would be tracking the wind quite diligently. I do want to double back to precipitation though. My When I refer to precipitation as rainfall, that is just one type of precipitation. Precipitation is any form of water from the atmosphere. And I know that I've mentioned this before when we were checking out rainfall, but precipitation is, it can be condensation on the ground, dew, frost. It can be liquid water, so rain for the sky, or it can be solid. So you can think ice and hail. So precipitation is any type of water from the sky to, not just rainfall, even though that is the most common one. That's usually what we look for checking out the. Okay. Hello. Now, to compare it to climate. Climate is long term. This isn't just a change in seasons. This is comparing year to year. So climate is something that is a condition for several years or several months. It's the norm, what you can expect in a certain area. So a very cold climate, let's say a polar region, so we've got the blue sections over here in the north, that would be a polar climate that is very cold. You won't get any rain. It's very little precipitation. It's technically a desert because deserts is any area that doesn't get a lot of rain. That's a desert. So even though it's cold and you don't think, sunny skies and dunes, but your polar areas are deserts. Um, we've got let's see, tropical over here, the red area. Tropical would normally be quite warm, very humid, a lot of rain. Um, Over the equator, you would get rain all year round, very consistent. In your subtropical areas, it's not really labeled over here, but in your subtropical areas, it's very similar to the tropical. It's also very hot and humid and rainy, but they have their own version of a dry season. And I use the term dry season very lightly because it's not really dry. It's just a few months where they don't get as much rain as you. So they'll have a rainy season. So that's your subtropical. All of these little characteristics um, give us the different climates that. And I know the Western Cape has a very interesting climate. So you can see that itty bitty little orange spot down over there, and there's a few more there, and all around here. And that's a Mediterranean climate. It's one of few areas that gets rainfall in winter. And I believe that most places get rainfall in summer. So winter is their dry season, summer is their rainy season. But in the Western Cape, we get our rain in winter, and then summer is our dry season. Okay, but now we wanted to see why we have these different climates. And the first one, the most important one, I would is latitude. So latitude is how far something is. Okay, the next one is distance from the sea. That is because the sea influences how um, extreme temperature conditions on land can be. Then we have altitude. Altitude is how high up something is from sea level. So that is an important point. It's not just meaning it's high up in the mountain, it's from sea level. Okay, then ocean currents. Ocean currents play a very big role. So warm ocean currents bring humidity, cold ocean currents don't. We're going to take a look at that. And then finally, relief. So relief, or in other words, how mountainous a place is. Relief, you might remember from when we looked at types of rainfall and we looked at relief rain. So we're going to unpack that one a bit as well. It does also influence temperature, which parts of the mountain get sunlight. Okay, so let's start with latitude. Okay, latitude is quite a straightforward one. Latitude is how far we are from the equator. So if we are on the equator, like you can see there's the equator cutting the Earth. If we're on the equator, the sun will be shining directly overhead and straight onto the Earth. What that means is that the sunlight is very concentrated. You can almost think of it as a magnifying glass. I don't know if you've ever tried to like burn a piece of paper or a leaf or something like that using a magnifying glass. It's the same concept. So you have this light that is the sunlight that is concentrated onto the point and it makes it hot. But at the same time, if you pull the magnifying glass away and suddenly the light goes everywhere, it doesn't have that same burning effect. And that's what we have at the poles. So here the light is very spread out. So it doesn't have that heating because it's not as focused. You have the same amount of sun. So it's not like the equator gets more sun. They have the same amount of sun, but the equator doesn't have to share it. The poles does. So you can see how spread out that sunlight is. Because it's so spread out, you don't get as much light per area. That makes sense. Okay. Then my next point is distance from the sea. This is a very powerful factor. So water water heats and cools very slowly. If you're swimming in a swimming pool on a hot summer's day and you get out the pool and you stand on the bricks are quite hot. And you occasionally burn your feet and you jump back into the pool. So even though they're both experiencing the same weather, they're both experiencing the same beautiful sunny day, the pool isn't as warm as the bricks. And the reason why is because bricks are a little bit hyperactive and they go in both directions, very extreme with any kind of temperature change. So you give the bricks a little bit of heat and then it runs to becoming hot. You give the water a little bit of heat and it doesn't really know what to do with that and it'll maybe change it. So you can think of the water as being lazy. And I always say this to my students, the ocean is lazy. It doesn't want to change. The land is a very eager being. You tell it to get warm and it will go right ahead and it'll get overly hot. The ocean, you tell it to get warm and it's like, but I just got cool. I don't want to. So the ocean is very lazy. And what that means for climate along coastlines is that along the coast, it doesn't get as hot or cold or as extreme as it would inland. So remember, inland will suddenly get very hot or very cold, but the ocean doesn't want to change. So the coastline is usually quite moderated. So we saw that the town further inland or the city further inland didn't change or it changed a lot more in the temperature from day to night. During the day, it was more or less the same temperature as along the coastline, but at nighttime it got a lot cooler. Then it works the other way around as well. So in summer, you can have scorching 40 degrees inland, and along the coastline it will be like a mile 25, something there. And then at night, it will suddenly drop to, let's say, 15 degrees, and the coastline stays at maybe 20. That doesn't just change day to day, it also changes season to season. So generally along the coastline, they'll have a lot more mild summers and winters, but inland it becomes a lot more extreme. So inland, you've got incredibly hot summers versus incredibly cold. Um, the the way that the ocean will influence the coastline also depends on if the ocean currents are warm or cold. So where I was showing you now, that was next to a warm ocean current. So it will also have the effect of warming East London. But if you go into the other direction, if you go towards the Western Cape, there we are next to a cold ocean current, so it have the impact of cooling the Western Cape. Okay, I think I've explained that. Yes. Altitude is height above sea level. This is usually where I break a few little brains, but please bear with me. I'll explain. Now, here's something to come to terms with. The sun doesn't heat the atmosphere. Yes, sun does not heat the atmosphere. Okay, what I mean by that. The radiation that we receive from the sun is UV radiation, ultraviolet radiation. That doesn't really have a heating effect on the atmosphere. Instead, that radiation gets absorbed by the earth. And then the earth will use that energy, use that radiation to create terrestrial radiation, infrared radiation. That terrestrial radiation is warm, and that terrestrial radiation is what heats the atmosphere. One way to think of it, an analogy that I often use in my classes, is to think of an electric stove. So an electric stove is powered by electricity. You give the stove electricity. The stove turns on, and the stove uses that electricity to heat the plate. It's the same system, and what that means is that the further away you get from the earth, the further away you are from the heat source. It moves away from the heat source. It also doesn't have as much mediums to hold it. if I can show you kind of in this diagram, yeah. If this is the surface of the Earth, gases have mass, they have weight. So they're pulled down by gravity towards the surface of the Earth. So around here at the surface of the Earth, it's very dense. We have a lot more compacted gas, which means that there's more molecules that can hold on to the heat. So when the surface, the Earth releases that infrared radiation, once it releases that heat, the molecules over here will absorb it, they'll reflect it, and they'll just hold on to that heat. But as you go up further and further into the atmosphere, you'll notice that it gets a lot thinner and it's a lot lighter. It's only the very light molecules that float up to the top. All of the heavier molecules, they sink to the bottom. So there's less here to catch that. So there's two reasons why it gets colder with altitude. The one is that we're moving away from the stove heat source, and the other is that there are less molecules here to hold on to the. Okay, I think we're doing pretty well so far. Regular climatologists. Okay, now we get to ocean currents. This map looks really cool, but it's referring to deep ocean currents. Right now, we're just looking at surface ocean currents. This is the one that I have. Let's take that one. Yeah, that looks really. Okay, so this is at the equator, and at the equator you can see that there's a lot of red. So these are all the warm ocean currents. And as we go towards the pole, there we can see all of the cold ocean currents, the blue. And same thing in this direction. There we go, all blue. Okay, and you will see that it moves away from the equator and it goes towards the poles. And the same thing with the cold ocean currents, it moves away from the poles and it comes up to the equator to get heated up again. And you'll notice something of a trend. So you'll notice that the warm ocean currents are always on the side. So look at all of these different continents. There it is to the east of South America. There it is again to the east of North America. Australia is just chaos. It's just got warm ocean currents in every direction. So they're a bit of an anomaly. But let's go to Africa over here, the same thing. Eastern side of the continent, and that also looks like chaos. Then if we look at the cold ocean currents, so the blue ones, are all on the western side. So they're the west of South America, west of North America, and west of Africa. This is where I like to remind my kids, no, you don't have to learn all of these ocean current names, but you do need to at least know how to know the Benguela current and know the Agulhas current. Okay, so these ocean currents influence the climate next to the continent. So let's take South America since it's right there. We have the Brazil current moving here from the equator towards the poles. It is a warm ocean current. What that means is that it will warm up this side of South America. It will bring warmth and it will also bring humidity. This side, the Peru current is cold, and what that means is that it will bring cold conditions, but it will also be dry. To kind of try and explain this, I want you to imagine a pot of water on a stove. If you put a pot of water on the stove and turn on the stove, it will start boiling. The water will start to get hot, and the water will release steam as it boils. That steam is humidity. And if you don't have a nice extractor fan, that humidity will start to condense all over your kitchen, and then you have moisture everywhere. That humidity brings in rain. But let's say on the other side of the situation, we have the pot of water, put it onto the stove, and you don't turn it on. It stays cold. It's not going to boil. It's not going to steam. You're not going to have water all over your cupboards. Okay, so in the cold ocean currents, you don't have as much evaporation. So you don't have the same humidity, don't have the same amount of rainfall. So what that typically means is that these parts of the tend to be dry. And South America is actually a very interesting comparison to make because I'm sure you would say that these, let's just find it on. No, why do I keep, okay, there we go. You would say that that doesn't look very dry. No, because latitude has more of an effect than ocean currents. So if we look all across the equator over here, it looks very green because the equator or the areas around the equator get a lot of direct sunlight. And with that direct sunlight, it heats these areas, meaning more humidity, more rainfall all around there. So what I was busy saying is that you'll notice along the western sides of these countries, it looks dry. Over there, we can see it by South Africa or Southern Africa, South America over there, North America, there you can see it. And I'm sorry, Australia is in a bit of an anomaly. It does its own thing. Even though it's surrounded by these warm ocean currents, it's still very dry. Yeah. I think I missed a slide, so let's go back and check. Yes, I did. So warm ocean currents on the eastern coast means warm conditions and more moisture, more humidity. Cold ocean currents mean colder conditions, less moisture, less humidity. A very dry condition, yeah, a cold current by sides. Where you see all of this desert, so here it's quite clear. Northern Africa and Australia does also fall into that category. Where you see all of this desert, that is a result of global circulation, global atmospheric circulation. So that is a little bit more complicated, but if you guys remember when we looked at high pressure and low pressure systems, so we were saying that where there is a high pressure cell or yeah, a high pressure system, you don't have any rain. If you're not remembering this, this is from the El Nino and La Nina video. So there I explained that high pressure systems come with dry conditions and low pressure systems rain. So that is why another reason why we have so much greenery over here and dry conditions here. I'll have to do a separate video for global atmospheric circulation. That's not quite grade 8 level. Okay, we get to mountain relief. So I'm first going to explain the impact that it has on rain before we get to temperature. Actually, let me just. No, let's do temperature first because I want to see maybe we can do a diagram for the rain one. Okay, the two different sides of the mountain, and this also applies to valleys as well, get different amounts of sunlight depending on latitude. Again, latitude comes into it. Latitude really is the most important factor, it seems. But depending on what hemisphere you're in, the certain sides of the mountain will get more or less sunlight. If you are in the northern hemisphere, the south facing side of a mountain or a valley will get the most sun. It will be the warmest area and also the driest. Then the north facing side will get the least sun or possibly no sun, making it coolest and also the most humid. Hello, welcome back. So I've created this little diagram to kind of try to explain it. So this is supposed to be the Earth, and these are the different beams of sunlight. So you can kind of see that each of these beams is the same amount of light. And they shine in, and if you've got it shining on the equator over here, and that's where I've put a little mountain. That's supposed to be my version of a mountain. It's got a little snow on the top. And here you can see that the sun is shining directly onto the mountain. And both sides of the mountain are getting the same amount of sun. But if I put a mountain over here, you'll notice if you compare that side, that this one seems to get more sunlight. It's shining almost directly on that side. I'm going to put one more there, and same thing. That side is getting all the sun, and this side seems to be facing away from all three of these. That one, oh sorry, two. That one and that one are all north facing. So it's in the southern hemisphere. The north facing sides get the most sunlight. You can also think of it as the side that faces the equator gets the most sun. And then if we put something onto the northern hemisphere, there's our mountain over there. You'll see now that side gets the most sun. And this side is quite shaded and sheltered. Add one more. There you go. There's all the sunlight over there, and that side is facing away from it. And in some cases, this side will actually get no sun at all. It will always be in shade. So in the northern hemisphere, we can see it's the sides that face towards the south. They get them. Okay, now I want us to take a look at how the relief influences. We have the moist air blowing in from this side of the mountain. It reaches the mountain, it's got nowhere else to go up. The moist air then rises and cools. That cooling means dense rain, and that side will have a lot of vegetation, a lot of greenery from all the rainfall. Then, as it gets to the other side of the mountain, this side, the air will have rained out already, so there isn't much moisture left. As it sinks, it dry and it actually heats up from the sinking, meaning that this side of the mountain gets very little rainfall and it's dry, hence rain shadow. This is the windward side. This is the leeward side. Okay. And I think that actually brings me to the end of my notes. Yes. Like I said, this was meant to be a basic overview of factors that affect climate. We're mainly looking climate as is supposed to be temperature and rainfall. Obviously, there's a lot that goes in climate, um, and a lot more that influences climate. So I mentioned the whole global circulation, the atmospheric circulation. That is a topic that time. We also have microclimates. We very briefly kind of looked at that when we looked at relief, but we have different types of climates in valleys as well because of the topography. And we also have different climates based on settlements and urban developments. So we refer to that as well as the heat island effect and urban climates are separate topics for this. So there's a lot more that can still be unpacked, but this was meant to be a basics video for my grade 8 students or other students who are freshers. And I hope that this is hey, thank you for bearing with me with all of my technical problems. I hope that you learned something interesting. I hope that this was helpful and answers all the questions that you came with. I hope that you have a lovely day further. See you next week. Hey, cheers. Have a great day.